31%. We got 750 parents. These are all facts. But if I went inferential on this and I made an inference, it really is almost exactly the same thing. It's 31% of all parents support their kids. Until they graduate college. Is that necessarily true? No. Is it true for the 750 parents? Yes, that's descriptive. It's facts. Inferential is applying that 31% of all parents will also support their kids until they graduate college. You're leaping back in feet first, Triton. Nice job. And that is all of 1.1. We've done a third of the first chapter already. Okay, qualitative data. Qualitative data is all labels and non-numerical descriptions. Quantitative data is all numerical measurements or counts. Everybody know what numerical means? A number. There are some numbers that are not considered to be measurements or counts. They're considered more of a label. Can anybody think of one of those? A number that is more of a label than a measurement or a count, right?
Phone number?
A phone number. A phone number has nothing to do with you, right? If you say to somebody, what's your phone number? You wouldn't be like, no, wait, let me guess. Okay, you look like you're about 5'11", so it must start with 5 and then 1. And then I would say like the color of your eyes, if I looked at a color spectrum scale, was like 406, so that must be next. And like, it's nothing to do with you. It's just a random number they gave you. I guess the area code, what matches where you are. Carter, you with me? Okay. I know, this is tough, but you got to make it through. Anyway, it is just a label. Another one. Address is, no, I would say that's not true because, like, if you were like 601, the one next to you would be like 599, right? Like, they go in order. So that kind of makes sense. Like, telephone numbers don't necessarily go in order, yeah? Jersey numbers, that has nothing to do, like, if you're number 1 on the football team, that does not mean that you're the fastest. It does not mean that you're slowest or the tallest or the whatever. It means that you pick number 1. Although it might mean like a position, right? Like there are certain ranges that imply position, but still, the number means nothing to you. Everybody understand? Okay, so here we go. Population of several U.S. cities are listed below. Which data is qualitative and which is quantitative? We've got cities as one set of data and population is another set. What do you think? Triton.
So the qualitative data would just be the city? Right?
Yep, that's a city name. This is a label over here. This is qualitative.
And then the quantitative would be the population.
Yes, that is not just a number. It's not like you ask somebody, hey, how many people are in Miami, Florida? And somebody said, well, my favorite number is 408,750, so write that down. Like, they counted people. That means something. It's a number that means something. All right, now there are 4 levels of measurement. This is the thing that we had the flow chart for in Math 9, or not Math 9, in Stats. I don't have a flow chart on here, although on the next page I do have something that will help you organize your thoughts. So if you want to keep the flow chart, then keep the flow chart from that class. Nominal level is only qualitative data. It is just basically labels. Labels or description. Ordinal data is qualitative or quantitative. This is the only one that could be either. It's something that you can put in order. that is not alphabetical. A good example of that is, let me make sure it's not on the next page. Okay, a good example of that would be this. If I said, t-shirt, or like here, let me do an example under each one. Like, what color is your t-shirt? My t-shirt is purple, or maybe it's blue, or maybe it's red. That's a good nominal thing. If it's ordinal, I might say small, medium, large, extra large. Do you see how I'm putting those in order? There's an order to those, size order. That's ordinal. Also, any kind of rankings go under this one. Like who won a race. Interval is only quantitative. And 0 is a position on a scale. For example, what temperature is it outside? It could be 0 degrees outside, it could be 5 degrees outside, it could be negative 5 degrees outside. 0 does not imply that there's no temperature outside. It's just kind of a position on a scale. That's interval. A second ago it was 1 degree outside, now there's no temperature out there. And then a bit, there's going to be negative 1. Yep.
That would change it using that Kelvin, right?
Right.
That's absolute zero.
Right, because Kelvin's does have absolute 0. Okay, is Kelvin an exponential scale or is it linear? Is the difference between...
I think linear, but I'm not sure.
Okay. Ratio level of measurement, that's the last one. Ratio level of measurement is quantitative. 0 means none. A good example of that is, how many cats do you have? If I say I have no cats, it means that there's none of them. 0 cats, no cats. It wouldn't just be a position on the scale of cats where I could have negative 2 cats or positive 2 cats. Can't do that. Okay, this is kind of like that flow chart. Nominal, you can put data into categories. Yes. Can you arrange it in order? No. Can't subtract data values and can't. One isn't a multiple of the other. This is also a twice test is a good thing called the ratio level of measurement. That means you can have twice as much as somebody else. This is always confusing, so I'm going to say it slow and sweet. Listen to me, please. Imagine that you're looking outside, okay? And outside it is 4 degrees. If it is 8 degrees the next day, is it twice as warm? I know 4 times 2 is 8, right? But it's not twice as warm, because what if it was 0 degrees outside? You can't multiply by 0. You see what I mean? Like, if it was negative 2 degrees outside, then if it's negative 4, is that twice as cold? Or if it's positive 4, now what is it? Negative 2 times as much as it was before? It makes no sense on that interval measurement. All that matters is just adding or subtracting, as in it's 4 degrees warmer today than it was yesterday. That's something we can get a hold of, but you can't say twice as warm. Because if it was 30 degrees and the next day it was 60, which can happen because it's Minnesota, that would be twice times 2